In this video, we're going to go over the Unit 4 practice tests. Even though there is a key at the end of the document that's uploaded in Moodle, this will go through the calculator steps and what you pushed and what went in for what section of the TVM solver. We will use the TVM solver quite a bit, although the first few questions don't really need that. Let's start with number 1. A friend lends you $520 and you agree to pay after 6 years with a 5% simple interest. Now, simple interest is just principal times rate times time. So we'll be able to figure out how much interest we need to pay first and then how much we'll have to pay altogether. So the interest that I'm going to wind up having to pay is the principal, which is $520, times the rate, which is 0.05 as a decimal, and then the time, which is 6 years. So we're just going to need to multiply those numbers together. We'll get $156. So that's the interest. But you don't just pay the interest, right? You pay the interest plus the amount that you borrowed. So we're going to have to pay back $676 altogether. So no TVM solver needed there. Suppose you found a CD, a certificate of deposit, that pays 3.5% interest compounded monthly for 4 years. So if you put $5,000 in now, how much will you have in 5 years? So the amount that you have in your account after a time of compound interest is principal, 1 plus r over n raised to the n times t, where the amount is how much is in the account after all the time has passed. So this is going to be 5,000. 1 plus the r as a decimal, 0.035. Monthly means I have 12 compounds, and we're going to let this go for 4 years, and then of course it's 12 times a year. I'm going to put this in my calculator as 5,000. 1 plus 0.035 divided by 12. But when I raise this, I need to multiply that 12 times 4 first, or I would need to put it in parentheses. I know 12 times 4 is 48. If you are dealing with numbers that you can't multiply off the top of your head, and you have an older calculator like I'm using, you're going to want to put those guys in parentheses, so that way all of the multiplication is done up in the exponent. In 4 years, you'll have $5,750.20. How much interest did you earn? Well, you put in only $5,000, so all the money that's over that is how much interest you earned, which would be $750.20. Now, suppose you really want to have $10,000 in 6 years. So when you're done in 6 years and you close out the account, the amount that's in the account is $10,000. How much money would you have to put in now? So this is a little bit more complicated. You can use the TVM solver, but it's probably just easiest to solve for P, even though it looks a little complicated. Notice that this part right here is really just this part, right? I can get a number for all of that, even though it doesn't look very nice. I can say 1 plus 0.035 divided by 12 raised to, well, now I want 6 years, right? So I need to change my 4 to a 6. And 6 times 12 is 72. So I have 1.2333. That's what this part is here. Times P is equal to 10,000. So what number times 1.2333 would equal to 10,000? So all I need to do to solve this is divide both sides by that 1.2333. So I'll say 10,000 divided by 1.2333. $8,108.33. If you put that in now for P and let that compound at 3.5% for 6 years every month, and 6 years, you'll have the 10,000 exactly. Suppose you had a choice of these investments. Which one would you choose? It doesn't really matter how much money you decide to put in to begin with. So I like to just use $1 because then I don't have to really multiply by anything and I don't have to worry about it. I'm going to still use my A equals P 1 plus R over N raised to the NT, but I'm just going to let P be a 1, so that way it just kind of disappears and I don't need to worry about it. So if I put in $1, which one's going to give me the most amount of money at the end of the year? Well, I'm going to clear my screen out because I'm going to have a whole bunch listed on here. If I have 4.5% compounded daily, and we're going to assume 365 days in a year, it's 1, which I don't need to write, times 1 plus 0.045 divided by 365, since we're compounding daily, raised to, and this is for 1 year, so it would be 365 times 1, so easy enough to multiply that, even though it's a relatively large number, 365, and so I just raise that to the 365, and in 1 year, if I put in $1, I'll have $1.05. So that's 105. But what if I change this to 5.8% and compound monthly? So I can hit second enter and back over this and change my 4.5 to a 5.8. Change my 365 to a 12. I'll delete that extra one. And then I'll change this to a 12 because N times T, where T is just going to be 1 year. So I just need to get rid of that extra piece. And if I put in $1 at 5.8% compounded monthly, I'll have 1.06. So that's already a little bit better. What about 4.3% compounded yearly? I'll say second enter again. Back up over this and turn this into 4.3. If it's compounded yearly, it's only once to the 1. Right? 1 time a year for 1 year. $1.04. And if it's simple interest, your principal times the rate times the time in years, that's your interest. And you had $1 in there, so you would have the 105 again. And so your best bet is the 5.8 compounded monthly. That's what's going to give you the most amount of money at the end of the year. In this case, a whole extra penny. Number 4. So North Carolina Education Lottery is a drawing for the Powerball twice a week. We just had a lot of big Powerball winners not too far from here. One was in South Carolina. Each ticket costs $3. It's actually $2, but we're going to pretend for this problem it's $3. And Chris used to buy a ticket for every drawing, which is weekly. So every week for the month he bought. We're going to assume 4 weeks in a month. And I guess there is 2 a week. So he's spending about $24 a month, right? Twice a week, 4 weeks a month, so that's 8 times. Each one costs $3. So he's spending $24 a month on Powerball tickets. He decides after taking this math class that he's probably better off doing anything else with that money, and he's going to take that $24 a month and he's going to put it into an account that earns an APR of 2.8% compounded monthly. So what would he have after 8 years? So this is a TVM solver. I'm going to go into apps, enter. TVM solver. After 8 years, putting away money every month, he would have put money away 96 times. He'll earn 2.8%. We're going to say he started out with no money in the account. And then he started by making payments as $24. I'm going to scoot down to this PYCY. This is periods per year and compounds per year. It could be different, like if we used it to do our simple compounding problems like for 2 and 3. But those are easy enough to kind of just do by hand that every time we use a TVM solver in our course, it's always going to be PY and CY are going to be 12. I'm going to back up over the future value. Well, how much will I have? I need to clear that out and then hit alpha, enter. And Chris would have $2,579. And to the nearest cent, he'll have 9 cents. That's pretty good. Number 4, you decide that you can afford an $800 a month mortgage payment. You're going to get a 30-year loan at 5.4% interest, which is a lot nowadays, but at one time it was actually a pretty good rate. So how much of a loan can you afford? So we're going to go back to our TVM solver. And for 30 years every month, we're going to have to make a payment. We got a 5.4% interest. The payment that we're willing to make is $800. Now the future value of the mortgage is going to be zero. Eventually you're going to pay that mortgage off, and the mortgage note is going to have a value of zero because the house will be paid. But when you start with a mortgage, that's when it starts high, right? And then you pay it down. So what I need to do is find out the present value. What's the loan value that I'm going to get at present? I'm going to clear that out. Alpha, enter. And I can afford $143,467, and when I round, 70 cents. I'm trying to get rid of my dots. There we go. How much money will I pay in total to the loan company, though? That's different. I'm going to go out to the main screen. Every month I'm going to pay $800. I'm going to do that for 30 long years. So after all said and done, I will have paid them $288,000, right? That's a big difference. So how much is interest? Well, this was the loan. Oh, handy little O in there. This is how much I paid. The difference between the loan and what I paid is the interest. So I'm going to take out the note part that we found before. And I paid $144,532.30 worth of interest. And that is pretty common for mortgages. You pay a lot in interest. Number 5. You're going to buy a home that's $319,000. You got a bank that will give you a 30-year loan at 4.8%. Back to the TVM solver because we want to know how much this payment's going to be. Well, for 30 years every month you're going to make a payment. We don't know what it is yet, but we'll find out. It's 4.8% interest. The present value of the mortgage note is $319,000. When you pay it all off, it will be zero, so I'm going to leave that zero there. I'm going to clear out the payment section. And if I say alpha, enter, my mortgage payment is $1,673.68. If I pay that mortgage paying amount every month for 30 years, I'll have actually paid them $602,524.80. Oh my goodness. So how much interest is that? Well, the note was only $319. So I paid them quite a bit of interest. $283,524.80. So you take the course and you decide, well, maybe I'll send them an extra $50 a month on my mortgage, and maybe that will help save me some money. And you might be thinking, who cares about $50 when your mortgage payment is almost $1,700? But it actually makes a pretty big difference. It's an option that you have, is once you make that minimum payment that required from you, this guy right here, the $1,673, you can send an extra to hit the principal. And so if we go back into my finance and the payment TVM solver, I'm going to add $50 onto this. Now here's the trick, which is it's a little sneaky. You need to leave the negative on here. That's what allows the present value to come down to the future value of the zero. Right? So if you take the negative off, it's going to be it'll be too good to be true, and so you'll know that it's not right. Right? It'll say something like 130 payments instead of what we're going to find out. So if I add $50 to 1673, that becomes 1723. So I'm going to add $50 onto that, and I'm going to back this up and say, well, everything else stays the same, but if I add $50 on, how many payments do I need to make now? And it will seem like, well, I'm going to need to make a lot of extra payments just to be the equivalent of one of the, right, 32, almost 34 payments worth of 50. It almost doesn't seem worth it. When you clear out N, leave everybody else the same, leave the negative on the payment and hit alpha enter, you get 337.7 payments. So really, you would only have to make now, let's say 338 payments. Well, that's a lot less than the original, because the original was 360. So now, if I'm making 338 payments, and each payment is $1,723 and 68 cents, now I'm only paying back $582,603 and 84 cents. So I'm paying back a little bit less interest. Now my interest that I'm paying back is $263,603.84 compared to what I had before. I'm going to say new interest. So I'll be saving let's see, minus 283,524.8. I'll be saving almost $20,000. So how much do you save? You're going to save almost $20,000, $19,920 and 96. Now, my answer at the end of the key may be a little bit different because I might have just left originally the 337.7. which will give you a little bit of a different answer if you're talking about a payment. But it's only off by a couple of dollars, so it's not too bad. Well, actually, it's off by more than a couple of dollars, about $550. But you would probably wind up making the some type of half a payment at the end. Oh, I see taxes, so we must be close to be towards the end of the test. Jill lived and worked in North Carolina for the entire year. Now this is a little bit older, so you can see that it says 2013. Her AGI is 55,000. She gets a standard deduction of 3,000 and an exemption of 2,000. So not only is this old, I'm talking about state taxes. And state taxes and federal taxes, even though the calculation part will seem very much the same, the standard deductions and the exemptions are much smaller for state taxes. So we're going to use a chart that's a little bit easier to use than the one that we looked at in class and that you see in the textbook, in that once you get to that ladder, you don't have to climb it. So for example, Jill's got 55,000. For her adjusted gross income, she gets a deduction of 2,000 and an exemption of 3,000, so 5,000 is going to come off, and so she's got a taxable income of 50,000. So that puts her right in here. So she's going to have to pay $765 plus 7% of the amount over the 12,750. So 50,000 minus 12,750. is that much money. She needs to pay 7% of that, but she also has to pay that extra $765. So she needs to pay to the nearest whole dollar $3,373. Her effective tax rate, $3,373, divided by her taxable income is going to be about 6.7%. So now let's look at Steve and Claire. They're married. They live and work in North Carolina. Same story as before. They have an adjusted gross income of $124,000. They're going to get a standard deduction of $6,000. That's a little too good. And then they get $2,500 per person. So that's going to be $5,000. And so their taxable income is $113,000. So that puts them right in here. So they're going to have to pay $6,787.50. Plus, they're going to have to pay 7.75% of the amount over the 100,000. So they made 113,000. So 13,000 is how much is over the 100,000. And I'll have to figure out what 7 3/4% is of that. And their taxable tax bill is $7,795. And the effective tax rate, if we divide by taxable income, is 6.9%. Two more. These are more towards the beginning part of Chapter 4. I have expenses and incomes. We're going to assume a month has 4 weeks and a year has 12 months. We want to find our monthly cash flow. Remember, cash flow can be negative. You don't want it to be negative, but it can be. I make $1,100 a month from my job. I'm getting a student loan of $6,000 a year. So every month, that's going to give me $500. And I got a scholarship of $5,800, which every month is going to give me $483.33. So $483.33 plus $1,100 plus $500 is $2,083.33. So this is my income. Now what I got to do is figure out how much is going out. Well, $640 a month in rent, $80 a week for groceries, but I need to do that every week, so times 4. So that's going to give me a $320. Tuition and fees, I need to pay that twice a year, so $4,200 twice a year, so that's for the year. So every month is going to be $700. And I want to be well entertained at $190 a month. So I have $190 plus $700 plus $320 plus $640. And I am spending $1,850 a month. So that's a lot, but I'm in good shape because I'm bringing in $2083.33, and I'm only spending $1,850. So I have a positive cash flow of $233.33. Yay. College fund for my baby. You get an APR of 3%. You want to have that much money for whatever bizarre reason in 19 years. How much do you have to put away every month? Back to the TVM solver. I have 19 years, and I'm going to put away money every month. I can get an interest rate of 3%. My future value is 0, and then my present value is 0. My future value is $154,324. How much money do I need to put away every month? Alpha, enter after I clear it. Oh, more than you might think. $503.01 when I round. And that's your test. You can see that you have the answers through here, but they're in a little bit of a different order, and I'll scroll to this one. You can see that it's a little bit different because we went to a little bit of a different payment. I said $338, I think, this time instead of $337. But it's all set up so that you can scroll through and see some of the answers, and now you have the key. And we'll go over any questions you have when I see you again in class.